A precision factory floor turns raw timber into exact, repeatable geometry. The work begins by stripping away the rough exterior to expose the stable core wood underneath. By laying alternating blocks into a grid, the craftsman creates a composite panel. This alternating grain direction prevents the finished board from warping under changes in humidity. Heavy industrial saws slice the dense blocks into uniform strips. A constant feed rate prevents the blade from burning. Once the adhesive cures, the panels are fed through a wide belt sander. This flattens the surface, ensuring that all individual blocks sit perfectly flush against one another. A thin, even layer of sealant is applied across the exposed grain. Raw wood is highly porous and will absorb moisture from the air if left unprotected. The primer fills these microscopic pores, stabilizing the material and preparing the surface for final use. As the sealant dries, the panels move along the conveyor. Consistent spacing ensures adequate airflow around every piece for a proper chemical cure. The final shaping involves rounding the corners, which removes sharp edges that are prone to chipping. Workers perform a visual inspection, verifying that the mechanical tolerances meet the standard. Finished panels are racked vertically for packaging. Storing them upright prevents trapped moisture and allows the finishes to fully off-gas. To protect the surface during shipping, each board is wrapped in a specialized plastic film. The packaging machine uses a system of tension rollers to draw the plastic tight. As the board passes through the heated zone, the film shrinks to conform exactly to the panel's geometry. This creates an airtight seal that locks out ambient humidity and dust. An improper seal would allow moisture to creep in, warping the wood. The automated wrapper eliminates this risk entirely. The wrapped panels are carefully boxed in heavy-duty corrugated cardboard. The internal bubble wrap acts as a shock absorber, protecting the precise edges from impact damage. Hundreds of completed units are staged for global distribution. Elsewhere in the facility, raw veneer sheets receive a protective surface treatment via automated rollers. For thicker components, a vertical band saw removes bulk material quickly, followed by a pass-through an industrial planer. The planer uses rapidly spinning cutter heads to shave the wood down to an exact thickness. Maintaining parallel surfaces is essential for the joinery that follows. A heavy-duty guillotine slices through entire stacks of veneer at once. The red laser line allows the operator to align the cut perfectly with the grain structure. These perfectly squared sheets are now ready to be bonded together in the pneumatic presses. Digital manufacturing takes over for the more complex geometries. A laser cutter focuses a high-energy beam to burn precise patterns into the curved surfaces. The intense heat vaporizes the wood instantly, leaving a clean, carbonized edge that needs no finishing. For structural modifications, a CNC router steps in. The spinning carbide bit carves deep, repeatable notches into the curved brackets. Computer numerical control eliminates human error, guaranteeing that every notch is cut to the exact millimeter specified by the wireframe model. The resulting joints will interlock perfectly, distributing mechanical loads evenly across the final assembly. Despite the precision of CNC machining, the curved brackets still require manual finishing. Workers press the inner and outer curves against rotating drums to remove tooling marks. The abrasive paper strips away a microscopic layer of wood, leaving a smooth surface that feels natural to the touch. After hand sanding, smaller components are loaded into industrial tumbling barrels. Tumbling is a mass finishing technique where friction between the pieces slowly polishes the wood. This bulk process efficiently softens the edges of hundreds of parts simultaneously. Meanwhile, pneumatic jigs are used to rapidly assemble smaller subcomponents. The pressurized air clamps the pieces together with immense force, driving the adhesive deep into the wood's pores to bond the fibers permanently. A properly clamped glue joint is often stronger than the surrounding wood itself. Inside an enclosed booth, the wooden components receive their final lacquer. The parts rotate continuously as the spray gun applies a fine mist, ensuring an even coat that seals the grain against environmental damage. The finished parts are sealed in plastic to isolate them from moisture, then packed into standardized shipping boxes. This careful packaging preserves the pristine condition of the wood during transit. Final product is a beautifully polished wooden lid. Its smooth curves and natural grain pattern are the direct result of the finishing process. Every cut, sanding pass, and layer of lacquer contributes to this final aesthetic. In another wing of the industrial complex, raw materials flow into the pencil manufacturing line. Grooved wooden slats move along automated tracks, preparing to house the graphite cores that will transform them into writing instruments. A heavy metal press flattens the slatins ensuring the grooved channels are perfectly aligned for the graphite. Precise manufacturing requires perfect adhesion. An automated dispenser lays down thin, consistent lines of white glue directly into the machined grooves. Using exactly the right volume of adhesive prevents squeeze-out from altering the pencil's shape. Textured metal rollers compress the top and bottom slats together. The immense pressure forces the glue to penetrate the wood fibers deeply. Once the glue has fully cured, the blocks are milled down into individual pencil shafts. The automated sorting system drops the freshly cut, raw wooden cylinders into large collection bins. A continuous stream of coated pencils travels through a specialized trimming mechanism. High-speed cutting blades slice off the uneven ends, establishing the exact standardized length required for boxing and sharpening. The assembly line never stops moving. Machines bundle the light green pencil shafts, wrapping them securely in cardboard sleeves for stability. Grouping the pencils at this stage prevents surface scratches as they travel along the high-speed belts. The factory relies on these automated pathways to maintain huge daily volumes without bottlenecking. Branding requires both heat and pressure. A mechanical arm presses a heated die against a continuous strip of gold foil. The thermal transfer bonds the metallic lettering directly into the painted surface of the yellow barrel, creating a permanent, crisp label. Following ferrule attachment, digital control panels monitor the line speed. Precise timing is critical here. The conveyor belt organizes the finished pink pencils into a flat, single layer. This exact orientation ensures they feed smoothly into the final packaging machinery without jamming the arms. For premium artist sets, the final collation is done by hand. Workers place specific colors into molded plastic trays, protecting the delicate graphite from impact. The trays slide into branded boxes. These comprehensive sets organize charcoal and colored leads into a portable system, completing the transformation from rough timber to a specialized tool for creators. The same principles of mass precision apply to the garment industry. A robotic cutting head traces complex patterns onto heavy brown paper with flawless accuracy. These paper templates act as physical guides for the fabric layout. By optimizing the pattern arrangement, the factory minimizes wasted material. Even with advanced robotics handling the heavy cutting, human spatial remains crucial for the delicate task of pattern matching on the table. Before cutting can begin, the raw textiles must be relaxed. Workers use mechanical spreaders to pull massive rolls of fabric across the long tables. Fabric is woven under tension. If it is cut immediately, it will shrink and warp. The mechanical spreader lays down layer after layer without stretching the fibers, ensuring the material rests perfectly flat. By stacking dozens of layers, the factory can cut multiple garments in a single pass. The rollers guide the material smoothly, eliminating wrinkles that cause dimensional errors. To secure the layers, a machine spreads a thin plastic film over the entire stack. This creates a vacuum seal that compresses the fluffy fabric into a rigid block. At the digital terminal, operators use nesting software to calculate the most efficient layout. The automated cutter then takes over. A high-speed oscillating blade slices through the compressed fabric, following the digital paths exactly. The vacuum hold-down ensures that the bottom layer is cut just as accurately as the top. Workers then strip away the excess material, revealing dozens of perfectly cut panels ready for assembly. On the sewing floor, an overhead transport system dictates the workflow. Individual garment panels are routed directly to specific workstations, keeping the assembly line constantly fed. The operator uses a rigid guide template to maintain a consistent seam allowance. Above, the automated rail system tracks the progress of every piece. The mechanical overhead pulleys eliminate the need for manual material handling between stations. At the workstation, an industrial overlock machine stitches and trims the raw fabric edges simultaneously. This encloses the seam in a flexible thread structure that stretches with the garment. Handling delicate materials like lace requires human touch. The operator carefully manages the feed rate, preventing the needle from catching the fragile open weave structure, while maintaining a perfectly straight structural seam. After assembly, high-pressure steam ironing sets the final shape of the fabric. The heat relaxes the localized tension created by the sewing threads, flattening the seams perfectly. Quality control happens during the final folding process. The workers smooth the garments flat, inspecting for any missed stitches or fabric flaws. Sealing the apparel in plastic keeps out moisture and warehouse dust, ensuring the fabric remains pristine during long-term storage and global transit. A properly folded and sealed product is the final step in maintaining the standard. The sealed garments are boxed and integrated into the logistics network. In the end, the chaotic environment of industrial cutting and high-speed sewing yields a clean product. Finished athletic wear must provide structural support while remaining entirely flexible. Achieving that balance requires a manufacturing system that operates with absolute rigidity. The factory floor is an engine of precision, turning raw materials into reliable performance.